Okay, AQA, GCSE, Combined Science, June 19, Paper 1, Question 4. This is where the papers started getting a bit tricky. So first thing is to realise what's going on in this circuit. This is a circuit that has a light bulb in series with a pair of parallel resistors. And it tells us the resistance of each of these things. So that's 10 ohms. I'm not going to put the ohm sign. No, I will. That's 10 ohms. That's 10 ohms. That's 10 ohms. And you're being asked to work out what the total resistance is. So when things are in series with each other, you need to add them together. So it's going to be 10 ohms here plus, well, these two things are parallel with each other, so you've got to work out what the resistance is here together. And you actually don't have to do that for GCSE science, but you are supposed to know, and it's in the specification, that if you have resistors in parallel with each other, their total resistance is less than their individual resistances. So the answer here is, well, 10 plus a number that is less than 10 is going to come out with an answer of less than 20. Now this is sometimes counterintuitive, but I think one of the examples we had in class was, imagine a bucket with one little hole in it and it was full of water. And that's like trying to get the current through one resistor. The hole is like a resistor. And the water will flow out slowly. If we added another little hole in the bucket, the water could flow out that hole, and the bucket would empty quicker. So this would have a lower resistance because we've now got two little holes or resistors. And you can think of the same with these circuits. By having both resistors here, the current can flow that way or that way, and overall the resistance is going to be less than 10 ohms. You've got two paths now. So how do you answer this question? Because you have to explain it. Well, you might as well say what I've just done. I've said that the total resistance is going to equal the lamp resistance plus the resistance of the pair. And the pair in parallel are going to have a resistance that is less than 10 ohms. Now there's a little trick here. You can use symbols like this in your answers. That's fine. Right, next one. Again, something you cannot guess. The symbol, where it's a thermistor, so it's a type of resistor. So that's a rectangle. And then to show it's a thermistor, it's like a hockey stick. That's the thermistor symbol. Nothing else will do. And thermistors are special. They're the only component where if it gets hotter, the resistance goes down. Most things, when you heat them up, the atoms or the ions in the material vibrate more, making the current harder to flow, increasing its resistance. Thermistors are the other way round. When it gets hotter, because they're made of semiconductors, you get more free electrons. And the more free electrons means that the current flows more easily. That's not what you need to say here, though. All you need to say is how the current changes. Well, the current is going to increase because when we increase the temperature, the resistance, because resistance decreases. Done. Right. Next part of the question. Now this was a little bit tricky. So what you've got to realise is that potential difference that we sometimes talk about as being the push, making the current flow around the circuit, or sometimes we talk about is the energy that each bit of charge has got as it goes around the circuit. What we're actually doing when we measure potential difference is we're measuring about how much energy is needed or used going through the component. We say it's the work done moving through the component. So in this circuit here, the charges come out of the battery and work is done, or energy is transferred, getting through the bulb. And that's obvious because the energy is transferred away as light. And it comes to this part of the circuit here, and it can either go down or up, but it can't go down because the switch is open. So it has to go through the resistor. Resistors are hard to get through, so work is done there, so some potential difference can be measured there, and then it gets back to the battery. If you close the switch, look what happens now. The charges flow around the circuit. Energy is required to get through that bulb. But when it gets to here, it could either go through the difficult way through the resistor or this new, really easy way back through here. And that's the way all of the current goes. None of it's going to go through the resistor. And this gets called a short circuit. It's a bit like basically removing the resistor from the circuit. If you do that, I think the rest of it becomes a bit more simple to visualize, because if all the current's flowing this way, none's going through the resistor, no work is done getting through the resistor, so there are no volts across that resistor. So the resistor, the potential difference becomes 0. And the reason is that all the current flows through the switch, or the other path. Because it has 0 resistance, or effectively 0 resistance. Now the lamp, I found this a bit sort of difficult until I thought of this as having the resistor removed from the circuit, and now all of the volts from the battery, they're no longer shared between two things. The bulb gets all of the volts from up here, so the potential difference increases. And the reason for that is there's no longer any across the resistor. And that's the end of question 4.